Thursday's homework reviews word questions using GCF and LCM. Let's practice reading too so we can remember what we're looking for. Question 1. Pencils come in packages of 10. Erasers come in packages of 12. Philip wants to purchase the smallest number of pencils and erasers so that he will have exactly one eraser per pencil. How many packages of pencils and erasers should Philip buy? There's a few reasons why this problem is an LCM problem. First, we know that Philip is buying multiple packages of 10 and multiple packages of 12. In a GCF problem, he would be splitting up a number of pencils and erasers that he already had into smaller groups to find the factors. But here, he's buying one pack of 10 pencils, 2 packs for 20, and so on. Another hint is that we're looking for the smallest possible number of pencils that Philip could buy. If we were finding the greatest common factor, we wouldn't be looking for the smallest amount. So I'll simply start by listing out the multiples for pencils. Notice that I labeled it P for pencils, so I keep track of exactly what my multiples mean. And you'll do the same thing for erasers until you end up with a common multiple. We can see that our lowest common multiple is 60. That's the least number of pencils Philip can buy, where he has an equal number of pencils and erasers. But that's not the answer, because the question asks us how many packages of pencils and erasers should Philip buy? Well, we know that Philip needs 1, 2, 3, 4, 5, 6 packages of pencils to get to 60. And he needs 1, 2, 3, 4, 5 packages of erasers to get to 60. So, as always, you'll want to end that question with a full sentence. Philip needs 6 packs of pencils and 5 packs of erasers. That's an LCM problem. Let's take a look at example 2. Kiara baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? There's a few key reasons why this is, you guessed it, a GCF problem. First, what's Kiara doing? She's dividing or splitting up the cookies so that they end up in identical groups. That process of splitting up into equal groups is finding the factors, finding out how we can split up 30 and 48 into equal groups. Again, that word greatest, just like the word fewest or least, is a good hint that we're looking for the greatest common factor or the least common multiple. But don't rely too much on that word. You also want to make sure that the context or the situation makes sense for the math you're using. When we find GCF, we always want to start with our factor tables, and we want to go in order. 1 times 30, 2 times 15, 3 times 10, 5 times 6, 1 times 48, 2 times 24. Make sure that you're consistent about counting for each of those numbers until you've looped all the way back on either side of the table. See how I end up with 6 and 8? 7 is not a factor, so I know I've covered them all because I have increasing order, then decreasing. Now, the greatest common factor is the largest number that's on both lists. In this case, 6. So, am I done? Is 6 my answer? In this case, yes, because the question is, how many plastic containers will she need? The only way that she can split up, or I should say, the way that she can create the greatest number of groups with the same number of each cookie is 6 plastic containers. So again, full sentence, she needs 6 containers. If the question asked you how many of each type of cookie she needed, you would be able to say she needed 8 of the chocolate chip and 5 of the oatmeal.